Welcome to Key Skill 3. Now we know how to calculate the formula for the nth term. We're going to be looking at how can you calculate a specific term that you've been asked for. For example, find the 10th term in the sequence. So as always, we're going to start by identifying our A. A is the first term, 8, and our R. Well, each time I need to multiply by 2. Now I've been asked for the 10th term, so start by finding the UN, the nth term formula, a times r to the m minus 1. So 8 times 2 to the m minus 1. I could simplify this down a little bit if I wanted to by noting that 8 is 2 cubed. But I'm going to go straight in and say, because I've been asked for the 10th term, I need to make n 10. So here, where I had before an n, I'm going to change that to 10. So 10 minus 1 for the 10th term. So the final simplified down expression is going to be 8 times 2 to the 9. And I'm going to take my calculator and type that in. 4096 is the 10th term. So here as well I have a 10 to show I found the 10th term. So now we've got a decreasing sequence, so we know that R must be a fraction. So I've got A will be 30. That's the first one here. And R is going to be, well, what would 15 divided by 30 be? The 1 in front divided by the 1 behind. Well, I can cancel that down by dividing both of them by 15, and that's going to be a half. And we can check that here. 15 times a half, is it 7.5? Yeah. So our R here is a half. Now, although I've been asked for the 8th term, I'm always going to do the same process, which means I'm going to first find the nth term. Once I've got the nth term, simplify down, then I'm going to let n equal to 8 if I've been asked to find the 8th term. So un is equal to a times r m minus 1. Un is equal to 30 times a half m minus 1. So that's my nth term formula first. And secondly, I'm going to take the 8th term. I'm going to replace all of the n's with 8. Before I move to type this into my calculator, I'm going to simplify down. 15 over 64. Now we're going to look at a little bit more complicated questions. We should be very comfortable now with our nth term formula. Now, in this question, they've given us a sequence, so we can identify A and R. So straight away, I'm going to write down A is 1, R is 2, because each time it's times 2. And we've been told the sequence goes on indefinitely, and we've been given a term and we're asked for the term number. Previously, we've been asked, what is the 8th term, for example? So they've given us the term number, they want the 8th term number, and they've asked us to find the term. So the difference between term number and term is term number is where does it come in the sequence, and term is actually what is it. So for example here, the term number is 3 because it's the 3rd term in the sequence, 1, 2, 3. The term itself is 4 because that's the value. So we've been given the term 2, 5, 6, and we've been asked to say which term in the sequence is it. So what is its term number? So what we don't know is n. What we do know is that un is 256. So if you imagine the sequence goes on forever and ever and ever, at some point this is 2, 5, 6. And what the question is asking is, where in the sequence is this 256? So we start the process exactly the same. We write down our nth term. So using our A is 1 and our n is 2. Using our A is 1 and our R is 2. So 1 times anything is just going to leave it the same. So our formula is un is equal to 2 n minus 1. Now, instead of substituting in for n, we're going to substitute in for un. So whenever you have the term and you want to find the term number, you substitute it here for un. So I'm going to have here 256 equals 2 to the n minus 1. Now this is where your knowledge of logs comes in. We have here an unknown power. So the most efficient way to do that is to take logs of both sides. So log 256 equals log of 2 to the n minus 1. So the reason why we do this is now we can use the rule for logs. It said this power here can come down in front of the log and be multiplied. So I can rewrite the right hand side as n minus 1 times by log 2. So this power here has come down and in front of the log. Now this is really useful because now I can make n the subject. I'm going to move the times by log 2 to the left hand side and make it divide by. So this gives me now an expression for n minus 1. If you want, you can use your calculator at this stage, or you can move the minus 1 to the other side and change it to plus 1. I'm going to type this in now. So here's my log button up here. This will give me an answer of 8. So 8 is equal to n minus 1. I'm going to move the minus 1 from the right hand side to the left hand side and change it to plus 1. So my answer is n is equal to 9. So that means that 256 would be in the 9th place in the sequence. We have a similar question here. Which term in the sequence 1 over 10, 1 over 100, 1 over 1,000, etc. is 1 times 10 to the minus 6? So start out, we have our A. A is 1 over 10. R is, well, it must also be 1 over 10. Because 1 over 10 times 1 over 10 would be 1 over 100. So let's write down un. Un is equal to a times r to the n minus 1. 1 over 10 times 1 over 10 to the n minus 1. Now, we can simplify this because the bases are matching. Remember, this is the same as 1 over 10 to the power of 1. So we can add those. This is going to be 1 plus n minus 1. And we can simplify that a little bit with 1 minus 1. They would cancel out and we would just have n left. So here we would have un is equal to 1 over 10 to the n. Now, the term in the sequence they've given us is 10 to the minus 6. It's also useful to know that 1 over 10 to the power of 6 would be 1, and you would have here 6 zeros. 1, 2, 3, 4, 5, 6. You could solve this with logs, or you could rewrite these so that they're both in 1 over 10. So, for example, you would need to know that 1 over 10 power 1 is 1 over 10. 1 over 10 power 2 is 1 over 100. 1 over 10 power 3 is 1 over 1,000. So if we've got here 1, 2, 3, 4, 5, 6 zeros, this would need to be 1 over 10 power 6. By comparison, we can see that 6 would have to match up with n. So we would have to have here n is equal to 6. This would make sense because the first one is 1 over 10 with 1 zero. The second one is 1 over 10 squared, or 1 over 100 with 2 zeros. The third one with 3 zeros, etc. So it makes sense that the sixth one would have 6 zeros. The fifth example is a little bit interesting. It's something that I haven't seen in the exam questions yet, which makes me think that it could be asked. We've been given a number, 13,123, and we are asked if it's in the sequence. Now, the important point to learn now is that if a number is in a sequence, its end value will be a whole number. For example, here n is 1, here n is 2, here n is 3, here n is 4. It's not possible if it's in the sequence that it has an end value of, for example, 2.5. That would mean it would be in the middle of the second term and the third term, and therefore it's not actually in the sequence. So what we're going to do is we're going to use the same method. We're going to find the end value and we're going to see if n is a whole number. If it's a whole number, it's in the sequence. If it's a decimal or a fraction, it's in between terms and therefore it's not in the sequence. So the method starts the same. We write down our A is 2, R is 3 because 2 times by 3 is 6, 6 times by 3 is 18, and we write down our formula. UN is equal to A times R to the n minus 1. So we have here 2 times 3 to the n minus 1. That's our final formula for the nth term. We're going to put this number in here for our UN because it's a term, it's not a term number, so it doesn't go in for n. So we've got here 1, 3, 1, 2, 3 is equal to 2 times 3 to the n minus 1. It's not possible to take logs yet. You want to move everything away from the exponent with the unknown power. So that means that the 3 to the n minus 1 here, it should be the subject. It should be the only thing left before you take logs. So I'm going to divide this side by 2. So here I have 6561.5 is equal to 3 to the n minus 1. Now I'm going to take logs on both sides. Remember, you want to take the power here down and put it in front with the times. So make n minus 1 the subject by dividing by log 3. That leaves me left the formula for n minus 1. And the last thing I'm going to do is move the minus 1 to the other side, and it's going to become plus 1. So if I'm here, I'm going to move that here, and I'm going to have that as plus 1. I'm going to type all of this into my calculator now. Log 6561.5 divided by log 3. And the plus 1 doesn't go in the fraction, it's separate, it's on its own. So you can see that that gives me a decimal number for 9. You have to look quite far along, but it's not a whole number. So n is 9.000. 1, 2, 3, 4, 6, 9. So because n is a decimal number, this number 13123 is not in the sequence. Therefore, 13123 is not in the sequence. Stick around in Key Skill 4, we're going to be looking at if you've been given 2 terms in a sequence, how you can do a simultaneous equation to find A and R. So it's going to get a little bit more complicated. I hope you enjoyed the last Key Skill. Don't forget to do all of your questions, all of your exam questions as well. And I will see you in Key Skill 4. Bye for now.